Hello dear student, myself Arif Khan Pathan, senior lecturer MCS Writing Institute of Pharmacy. Now we are dealing with the second part of the antiseptic and disinfectant, in which we have to see the quaternary ammonium compounds. These are also called as cationic surface active agents. These compounds are derived from an ammonium salt, which has a general formula R n plus R4x minus, where R is nothing but what? The alkyl groups, whereas X, in this X is the halide radicals like chlorobromo or maybe a hydroxy, and these nitrogen positively charged means the quaternary nitrogen. That's why it is called as quaternary ammonium compound. Now what are the characteristic, or how these quaternary ammonium compounds are acting? As far as the mechanism of action is concerned, they are called as cationic surfactant because they are positively charged and they are forming positively charged ions when they are enter into the cell, and they are detergent property, helpful for cleansing of the dirt and wounds. Means these are surface active agents, and as these are surface active agents, will act on the cell wall, particularly the bacterial cell wall, because if you are talking about the surface active agents will act on the surface, and as far as the bacterial cell is concerned, the surface of the bacterial cell will be the cell wall. So these surface active agent will act on the surface or cell wall, will causes the denaturation of the protein as well as alteration of the permeability, results into leak down of the active constituent from the cell, from the bacterial cell, and results into a dying of bacterial cell. It results into killing of bacteria, killing of microbes, and hence these quaternary ammonium compounds are acting as a antiseptic and disinfectant. Again, these cations bring about the protein denaturation, which rupture the bacterial cell membrane, and hence there are antibacterial activity. Next, benzalkonium chloride. As far as these physical properties are concerned, it is white, pale yellow, aromatic, bitter taste, gel in nature, miscible with the water. Now this chemical property is important one. So as far as chemical property, the aqueous solution of this benzalkonium chloride will show the alkaline to the litmus. When we are checking by the litmus, so red litmus paper will get converted to a blue. It indicates that the solution is alkaline. So aqueous solution when we are preparing of benzalkonium chloride will be alkaline to litmus. And next chemical property is that these aqueous solution on the rapid shaking, it will form the foam. So it will form foam on rapid shaking. This is because of the detergent property of the antiseptic and disinfectant, or particularly the benzalkonium chloride. So this is all about the chemical property of benzalkonium chloride. Next, stability storage condition. It should be stored in tightly closed light resistance container. So that is the simple storage condition, or the for stability storage condition is there. It should be stored in tightly closed light resistance container. Now the uses are most important. These are used as antiseptic and disinfectants, which has a detergent property also, and that is detergent is for cleaning, and this detergent property for cleansing of the intact skin wherever there is a wound. Next, irrigating of the bladder or urethra of these particularly organs. So wherever cleansing is there, so irrigating solutions are used. So for cleansing of these, if there is a say infections, so in that case these benzalkonium chloride solution may be used as irrigating solution for cleansing of these tissues. Next, to get relief from the painful infections of mouth and throat, so these are the local anti-infective agents used to treat the local infections, such as mouth and throat infections are local infections. So these are used maybe in the form of, if you want to treat these infections of mouth and throat, we must have to apply in the form of mouth washes or gargles. Next, as a preservative in eye drops. So this may be behaving as a preservative also in particularly the ophthalmic preparations, which will prevent the biological destruction of the ophthalmic preparation. And wherever there is a sterility, say if you're talking about the eye drops which are ophthalmic preparations, so in these sterility is most important, and to maintain the sterility we have to add the preservative, and in this case benzalkonium chloride is the most preferable preservative added in the eye drops or eye ointments or ophthalmic preparations in order to prevent the biological growth and make it sterile or maintain it sterile. Next, pharmaceutical formulation of this benzalkonium chloride may be available in the form of solution and lozenges, Lozenges may be for throat and mouth infections, and brand names are Benza, Pedipro, and Tenac. Next, next compound, that is cetyl trimethyl ammonium bromide, that we call as cetrimide. Cetrimide stands for cetyl trimethyl ammonium bromide. So physical properties of the cetrimide: white, creamy white, faint characteristic odor, free flowing powder, as like our table salt, which is free flowing, non-sticky. Like same, this cetrimide has a non-sticky nature. So when we see in the original form of the compound cetrimide, it will be free flowing powder. Next, chemical properties: when it is treated with the potassium iodide in acidic medium, the quaternary ammonium iodides are formed, and which are soluble in chloroform. So this is the chemical property. Stability: storage as usual, stored in tightly closed container. Now uses: these cetrimide is most popularly used as antiseptic creams. Wherever the antiseptic creams are to be used or applied to treat the burns as well as wounds. Normally antiseptics we are using for cleansing of wound, yeah, prevent the sepsis into the wound, as well as in case of burns. Burn tissues, prevent the infection in the burns are again most important parameter, because burn tissue, if it got infected, pus forming cells are being forming out there, so results into a much painful condition. So one should have to avoid the proceeding infection or generating infection in the burn tissues. For that we must have to apply the antiseptics. Next, to remove the scabs from the skin. Next, to infect the as a disinfectant, maybe you utilize for disinfect the utensils, non-living things, particularly utensils, vessels can be disinfect wherever needed. So in this case it may be acting as disinfectant. First case as antiseptic, second case applying on non-living things, disinfectant. Again it may be acting as a preservative also. And last one use, that is emulsifying agent. The cetrimide has the lipophilic and hydrophilic properties and will able to solubilize the making stabilize the emulsion, and hence it may be acting as a emulsifying agents also. When we are preparing cetrimide cream, there is no need, because creams are emulsion, so there is no addition of the external emulsifying agent while preparing cetrimide cream, because cetrimide itself an emulsifying agent. So it may be acting as emulsifying agents also. Pharmaceutical formulation: emulsifying cetrimide cream, cetrimide emulsifying ointment as a emulsifying agent, as well as emulsifying wax and solution. Hexabyl C is the most popular brand. Hexabyl C is the most popular brand for the antiseptic, for this antiseptic cetrimide. Next, phenol, most important antiseptic and disinfectant. Phenol, normally if you're talking about the phenol, so it is prepared as 800 gram of phenol dissolved into a purified water to produce the 1000 gram, or we can say that 1 liter. So 1 liter of phenol can be prepared by dissolving 800 gram of solidified phenol or phenol crystals into the purified water. Now this is the structure of phenol, in which the benzene ring and hydroxy group is there. Hydroxy group means it's alcohol, and we can say that it's aromatic alcohol because it is attached to the aromatic ring. Now as far as the numbering of these phenol is concerned, we should have to start a numbering with that carbon to which the functional group OH is attached. So this is the carbon to which the OH group is attached, functional group is attached, so we should have to start numbering with this carbon. There is a restriction, and there is no restriction that we can proceed the numbering by clockwise or anti-clockwise. So this is the freedom. Next, as far as the physical properties of phenol is concerned, it is color like characteristic, and it's non and liquid nature, that the normally we had seen the liquefied phenol, so mostly it is available in the liquid. Chemical properties: when it is treated with the bromine water, it converts into tribromophenol. The reaction is a bromination, in which the phenol get react with the bromine but in the form of bromine water. So actually the 3 hydrogens got replaced at 2, 4 and 6 position. These 3 hydrogens got replaced with 3 bromo, and hence we can say there is a electrophilic substitution reaction, as well as there is a bromination. Simple, we can say that the bromination, the phenol undergo bromination and will form the tribromophenol as a bromide derivative. Next, stability storage condition is the most important. Is uncommon storage condition is there's phenol. It should be closed tightly. It should be stored in tightly closed light resistance container. But there may be chances of getting deposited the crystals when it is stored below 4 degrees Celsius. So in that case, one should have to give the instruction that in such case it is to be completely melted before its use. So no doubt, if it is being forming crystals, when accidentally or intentionally it is stored below 4 degrees Celsius, it results into deposition of crystals. So simply what we have to do, we have to dissolve it completely before the use of this phenol. Next, uses for the dressing of the small wounds. It may be used as antiseptics, cleansing, for cleansing. Next, to get relief from the itching. Next, as an analgesics in dentistry, because wherever there is say tooth extractions or teeth extractions are there, or tooth minor surgical procedures that we call a dentistry. So in this case, these as a analgesic, dental analgesic, phenol may be used as a dental analgesic. Next, as an antiseptic and analgesic in mouth ulcers and tonsillitis. Tonsillitis means the inflammation of the tonsils. In the, you can see the tonsils got infected, and this is a local infection actually resistant to inflammation of tonsil called tonsillitis. In this case, phenol may be used in the form of mouthwashes or gargles so that these local infections can be treated. As phenol, we are taking as a local anti-infective agent. Next and last use, that is in treatment of the boil in the ear. Maybe this boil means the pus forming lesion like are forming, and basically it's a bacterial infection which is maybe found in the middle ear or maybe outside the ear, that is an external ear, external ear or middle ear, and that is particularly the complicated place. So to treat these such type of infection, the antiseptics to be applied, antiseptic and disinfectants are to be applied. Next example include the chlorocrisol. So this is the structure of chlorocrisol. If we see, and we can see that in this structure there are two parts. Phenol, basically this is the phenol which is substituted with two types of substituent, methyl and the chloro. So this is the structure of chlorocrisol, which is a phenol and related derivative actually. So chemical name is concerned, chemical name will be, we will select the parent nucleus as a phenol. We'll give the numbering phenol to the phenol by starting with this carbon, and clockwise anti-clockwise way the last substituent will get the least number. So in this case, either we are going clockwise or anti-clockwise, that both the last substituent will get the fourth position. So in this case, we are giving numbering normally by clockwise way, and there are two substituents, methyl group at third position and chloro group at fourth position. So as per our rule, to give the chemical name to the given structure, the phenol is a parent nucleus which is at the last, we are mentioning at the last, and before that the name of substituent prefix with its position and needed to be arranged in alphabetical order. So there are two substituents, methyl and chloro. So alphabetically chloro come first, then come methyl. So we are mentioning the first 4 chloro, then 3 methyl phenol. So this is the chemical name for given structure chlorocrisol. Physical properties of chlorocrisol. It is a colorless, characteristic odor, crystalline powder soluble in water. Next, stability storage condition. They are stored in tightly closed light resistance container. As usual, storage conditions are there. Then uses powerful antibacterial agents as a fungicide, as a preservative, creams in the pharmaceutical preparations. So these are the uses of this chlorocrisol. Now formulation, chlorocrisol solution, and Valderma cream is the most popular brand available in the market for the given drug chlorocrisol, and the structure of chlorocrisol again the important one, and spasmidone again the another brand for the chlorocrisol. So this is all about the some compounds we had seen. We had seen the cetrimide, we had seen benzalkonium chloride, which benzalkonium chloride belongs to the quaternary ammonium compounds. Then we had seen the next cetrimide, again a quaternary ammonium compound. Phenol related derivative, in that two examples we had seen phenol and chlorocrisol. Amongst these, the structure of chlorocrisol is most important, which is the 4-chloro-3-methyl phenol. So thank you dear students. Next we will see the next part of the antiseptic and disinfect. Thanks for watching. Thank you so much.